you're going to once you go to the site, mute the video, okay?
Okay.
Because you know when we tutored, you saw the I used the blackboard,
Uh-huh.
right? This is hold on. You saw the I used the hold on the blackboard. Okay.
Yeah, the,
Hold on.
my former Skype account, it doesn't work for some reason, so I
Okay.
switched account.
All right. So go there, and you should see my screen.
Oh,
Good.
yeah, yeah. Oh
Mute
my
the
God.
video. Mute the video. Okay.
Yeah, I mute the video.
Okay. Because you're going to be talking to me, right? Because if you turn the video on, no, if you not mute it, you're gonna hear us talking again and again. Does that make sense?
Wow.
The YouTube is just there for you to see the screen. Okay?
Oh my God.
All right?
So smart.
Okay?
Okay.
Okay. All right. So we have until 3:30. Okay? So it's 2 hours. And last time we spoke, you wanted to cover chi-square test and the confidence interval, correct?
Mm-hmm.
Okay. I also emailed you the notes that we're going to go over if you want to go over that at a later time.
Mm-hmm.
So first of all, we're going to cover the chi-square test, then we're going to do some problems, then we're going to do confidence intervals, then we're going to do some problems. Does
Okay.
that work for you?
Yeah.
Okay. All right. So the first thing that you have to hear that we have on the screen is the basic definition of the chi-square tests. All right.
Mm-hmm.
The issue that you brought up to me is, Brian teacher, there are three different versions. How do I know which ones to use? Right? So the
Mm-hmm.
first one is your goodness of fit. This is the one that you're going to use a large most of the time on the FRQs. Goodness of
Mm-hmm.
fit. This will measure how the data set fits within a proportion, okay? So the first thing that you want to notice is what I underline here. You are testing one population only, right? And in
Mm-hmm.
this example, John wants to test whether the distribution of zodiac signs among his employees is even or not. We should expect one half of the employees to have each of the zodiac signs, right? Like, you know what the zodiac signs are, right? Like Aries, Taurus, Gemini.
No.
Okay, like, you know how the Chinese zodiac,
So yeah, hold on, let me search that word.
like,
Zodiac.
the dog, the dragon.
Oh,
Okay,
okay,
yeah.
okay.
So
Yeah, yeah.
this is just that. That's what the American means by the zodiac sign.
Oh.
Okay? So here, notice that the H naught, all the proportions, all his employees are equal. Would that make sense? Because that's the null. The null is always assuming that it is equal proportion. Good?
Mm-hmm.
Okay. That's the first key. The second is the alternative is that at least one of them breaks away or succeeds the one half proportion. Okay?
Okay.
That it's right. So the goodness of fit, one proportion, right? One population. It has to be one population, and it's trying to measure if it's outside of a expected distribution, which in our case we we want it to they are expected as one half. Okay?
What is one half?
Well, in our yeah, because there's 12 zodiac signs,
Uh-huh.
right? So we expect it to be 1/12,
Oh yeah,
right?
1/12.
Yeah, okay? But that's
Mm-hmm.
always like it could be when we do some problems you're going to see it's going to be different. But there's always an expected value that is calculated first. Okay? Good?
Mm-hmm. Mm-hmm.
Any questions about the goodness of fit?
No.
Okay. Now, the second one is your homogeneity. This is another name for the test of sameness. The difference between the goodness of fit and the test of sameness is that this is on a different population. Good? So
Mm.
here there are two categories. A lot of the time, each time you see like a chart like this where it has two different populations, in our example is a men is one population and the other population is women. That is going to be the homogeneity, or different population for the test of sameness. Okay?
It can be two or more, right?
Yes, but for the sake of your test, you're only gonna only be given two.
Two population.
Yes, but you
Okay.
mhm, right? Remember here the degrees of freedom is your. It's really the degrees of freedom always follows this format, right? A row, A stands for row, B stands for column. The
Mm-hmm.
degrees of freedom is defined as A minus 1 times B minus 1. This is
Mm-hmm.
always true. A lot of the times people think this is a different formula. It's not, because here, how many columns are there really? Right? There's only one column. So do you see how this degrees of freedom for the goodness of fit is just whatever your how many of the population is minus 1?
Yeah, so for homogeneity, how
Hmm.
many variable are there?
Here too.
Two variables.
Correct. It depends on
And
the amount of columns they are. The amount of populations they are. Yeah.
uh what? So it can be two or more variables. I mean the like the soccer, badminton, tennis.
Oh,
Yeah.
no. Here, yes, it could have different categories. Yes, but it's just the in terms of the population is the column. It can have different amount of rows. The rows doesn't matter.
Oh, okay.
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 Any other questions?
No.
Okay. Most of the time that the test of homogeneity is trying to measure is whether there is a difference between the distributions, right? Is there a difference between the population? Is there a difference between the men and the women in this case, right? Those are the
Mm.
difference in the population. Okay?
Mm-hmm.
All right, good. The last one, um, is your test for independence, okay? The difference between the test of independence and everything else is that this deals with what sort of variable? Look at it.
Cat Categorical?
Yep, that's it. The rest is not categorical, right? This is categorical because here, do you see how the values here are associated with yes or no?
Mm-hmm.
Okay, right? This is it, right? Because here you're trying to see if the two category variables are associated. Okay, so the last time we spoke, some of the categorical things that we talked about were the um, the colors of the car, right? So you could try to see if the colors of a car and the make of the car are associated, right? That would be a test of independence. Does that make
Mm-hmm.
sense?
Mm-hmm.
Okay, good. So
Mm-hmm.
here are your three examples of your chi-square tests. The most of the time you're only going to be dealing with goodness of fit when it comes to the FRQ. On the multiple choice, they might ask you for the other three, right? But only on the FRQ, they only deal with goodness of fit.
Like all the time.
Yes, right.
Um,
So we're gonna see some problems on the FRQ that deals with like you're gonna see the two columns, but it's still gonna be goodness of fit. Okay,
okay.
good. So does this clear up the difference between the um, types
So
of
yes,
child
yes
square?
or no question is categorical.
Yes, because in this case, they're asking them here. Jen collects data for a study to see if age is related to Alzheimer's, right? So these
Mm-hmm.
are the two categorical values that they're getting: the age and the Alzheimer's. Okay,
Mm. Mm.
right? Because the the number, right? Like the number of your age really doesn't have a value, right? And the
Mm-hmm.
Alzheimer's is, do you have Alzheimer's? Yes or no? Does that make sense why that's categorical?
What is Alzheimer's?
Oh, Alzheimer's is just a disease.
This
Okay. All right. Is this Alzheimer's or is this asthma?
asthma.
Oh, okay. That's okay. Asthma. Yeah. Okay. I misread it. Okay. Good.
Okay. Yeah.
Okay. The degrees of freedom for the
Oh,
test
yeah,
of
yeah. One
independence
more
is the
question.
same.
The
Yeah.
test for independence only has one population, right?
Yes. 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 But
Oh.
it's too. You wouldn't really say population. Yes, one population, but two categories in that population.
Mm.
Right? Because now you're wondering, wait, is the 10 through 20 different from a population from 20 to 30? Right? Are you wondering that? Is that why you're asking that question? It's
Mm-hmm.
really one population, right?
Mm. Mm.
That they're referring to. Okay.
And also,
hmm
why is yes or no question a categorical variable? Two categorical variables.
Why is yes or no categorical? No,
Mm-hmm.
in terms of Alzheimer's, like, do you have Alzheimer's or you don't have? Sorry, do you have asthma or you don't have asthma?
Okay. Or can like the categorical variable be not to be a yes or no question?
It could be do, it can be okay. Let's say Jen collects data in a study if age is related to the disease that you have, right? And it could be asthma, it can be um, diabetes. You could also have like blindness, right? Right. So
Mm-hmm.
this yes becomes diabetes, and no can be blindness, right?
Mm.
Does that make sense?
Mm.
Okay. Good.
Okay.
Okay. Any more questions in regards to the categorical or quantitative? It's going to make sense when we go to the problem, and you're going to see it work through.
Okay.
Okay. Good.
Yeah.
Okay. Now, here, now because most of the problems that we're going to deal with is going to be goodness of fit on the AP test, so I included here a complete test for you to look at in terms
Mm-hmm.
of the homogeneity of a population. Okay. So here,
Mm-hmm.
the study here is to determine whether there is association between race and opinions about their school. Okay, so they surveyed black parents, Hispanic parents, and white parents. Okay, and here
Mm-hmm.
they basically gave them the category of what do you rank the school: excellent, good, fair, or poor. Right? Do you see how these are all categorical?
Mm-hmm.
Right? Okay, and these are the different populations. In this sense, it's three, not just two. Right? Because there's black, Hispanic, and white parents.
Three population.
Yes.
Okay.
Good. In this
And like
example, there's three
excellent, good,
population.
fair, poor. Is that it has multiple categorical variables?
Yes, because the way they answer it is excellent, good, fair, or poor. Those are the four uh, categorical answers that they're referring to. Right?
Okay.
Categorical. These are your categorical.
So this one is homogeneity?
Yes, because these two are sort of related. Right? These two are sort of related, but yes, it is homogeneity. Yeah. I call it the test of sameness, basically. You're basically trying
Okay.
to see if the parents' opinions here are the same or
Uh-huh.
not.
Yeah, and also for the indi for the test for independence, how
hmm
many population and uh variables are there?
Uh, he- the definition of the independence for you guys, it's just it wouldn't. Hold on, let me. There, these two are always seen together.
Yeah, I
What's
had a
special is
question.
just the categorical, because I'm trying to wonder like a multiple choice question that like it would sort of ask. I've never seen a multiple choice question that has this as like B and this as C, right? It's they're always together. That's why you never
Mm,
see them apart. So they're almost the same thing, because the this is always dealing with the different populations, and this is always categorical. They're always the same, because notice soccer, badminton, and tennis are all categorical data, right? Because those are
hmm.
the sports that you take, right? So they're one of the same.
What? One of the same?
Yeah, like so the test for homogeneity and the test of the independence are basically almost the same. Because do you see how this and this are almost identical? Right? Does that answer your question? Because you're trying to like wonder like what is the difference? So most of the time this is one population.
Which one is one
Right
population?
here, this one. Because this is the age group, but you can always think, but a lot of the but for the sake of what you're trying to understand, you can think to answer your question, this is one population. But you can always consider this as multiple populations, right? If you
Mm-hmm.
do test for homogeneity,
Mm-hmm.
right? Because these are different populations in of
Yeah.
itself.
So for test for independence, can I
hmm
have like two or more categorical
Okay,
variables?
so in this data, like in this example, what are you thinking? Like Jen collects data from a study in. Oh, okay. Jen collects data for a study from to see if in USA,
Mm-hmm.
Korea, and China, right? Okay. If I change it to this, right? This would have three populations now. Would
Mm.
that make sense?
Mm-hmm.
That's how it would change. But
Okay.
most of the time, it's always one population.
Okay.
Okay.
Mm-hmm.
Does that answer what you're looking for? Does that clarify what you're wondering?
Mm.
Or no?
Yeah, so basically homogeneity and test for independence, the difference between them is the population.
Yes.
Okay. Okay.
Right?
Sure.
Because here you are wondering like, is this multiple populations? No, it's one population. It is the population of parents. Right?
Mm-hmm.
Okay? Right?
Mm-hmm.
Here, because you always have to calculate an actual and an expected, right?
Mm-hmm.
Now look at the null hypothesis, right? There's the relationship between the opinion, and the other one is there is no relationship. Okay, it this is because this population that they're referring to here are all the parents. Does that make sense? Why the null and the alternative is set up this way? Because this is talking about the whole population of parents at that school,
Mm.
right? Do you
So
see how?
this one should be test for independence.
No, no, no. This is homogeneity. No, that's why.
But
hmm
so how many populations are there? Three populations?
In here, in here, yeah, in here, when they calculate it, it this again. This is what I'm telling you. The homo the test for sameness and independence are basically almost the same. But in this question, they're not asking if these opinions are independent from each other. Does that make sense? Because look at what the researchers are asking. Researchers surveyed three random groups of parents and asked them, "Are high schools in your state doing an excellent, good, fair, or poor job?" This is not asking if the black parents, the Hispanic parents, and the white parents' opinions are different from one of each other, right? Yeah. Hold on. Good. Ah. Hello?
Yep.
Okay, you good? Okay.
Yeah.
Just let it cut off. Alright. Let me drop you back there. Okay. Alright. So, good? Are you good with the question? Here?
Yeah.
Okay. Here you can check out like how they run the child square, right? The degrees of freedom is exactly the same. So notice that let's just look at the state of the conclusion, right? Maybe this is going to give you better understanding of it being homogeneous, okay? So here this
Mhm.
says there is significant evidence, right, to reject H naught and conclude that there is a relationship between race and opinions about school, okay,
Mhm.
to determine specific comparison using a two-way table, right? Here they're saying that, for example, a greater percentage of white considers schools good compared to Hispanics, right? So here, do you see here that they are talking there that they're trying to that they're saying here that there is a difference between the categories between the Hispanics and whites and the black parents because they could
Mhm.
reject it, right?
Mhm.
So do you see how homogeneity and independence are almost the same tests? Yes or no?
Mhm.
Okay. All right. All right. Good. All right. So from
Yeah.
here, given the
I think
three,
there's a like a 5 seconds lag between your voice and the video.
yeah, yes, because it's a live stream, so there's always a delay.
Okay.
Right? Any? Okay.
All right.
That's why you don't. That's why. Do you want me to shut off the camera?
No.
Okay. Because I just care about the screen. That's why I didn't know.
Yeah,
So
yeah. It doesn't matter. Yeah.
okay. All right. So this is a really this the first. So this is. I would like you to work through this problem. Do you want to do the probability stuff first, or do you just want to go to the chi-square part of the question?
Yeah, I can do the probability first.
Okay, you want to do the probability first? All right. So
Yeah.
read the question and give me the first one.
Mm-hmm.
Like actually read it out. Contestants on game show spins. Uh, contestants on a game show spins. Hold on. Give me one second. Give me 1 second. Yep. So here they're asking what is the probability that the result will be a number on all the first three spins of the wheel. Do you understand the question?
Mm-hmm.
Okay. What do you have? I could pull it out here.
Uh,
Um,
what is the probability?
oh no. The screen captured the wrong thing. Add screen captured.
For part A, part A. You good?
Yeah, no, I'm waiting for your answer.
Oh, you're waiting for my answer?
Yeah.
The answer is 27 over 64,
Uh,
which
t-
is
is that wait, it's that something squared? What's that squared that you use?
3/4
Yeah,
the
3/4
cube.
squared. Yeah. No, yeah, 3/4 cubed. Yeah. Uh-huh.
Yeah,
Okay, good. All right, so
yeah.
that's correct. Um, next part B. What is the suppose a contestant earned 800 bucks on his or her first three spins and choose to spin the wheel again, right? So a fourth time.
Hmm.
What is the expected value of his or her total winning for the fourth time? Okay, you want to do that next?
Hmm.
Give me that. So he can either win zero. What else could he win? He can either win what?
Um, 900,
Good?
1,000,
1,000.
and 1,300.
Alright. Now you want to assign probabilities to each one of those. Right? Because
Yeah,
if he lands
yeah,
on sunk, he gets zero. Okay.
yeah.
So these are all what?
So
You
the
want me to do
expect
fraction or decimal?
hmm?
Fractions or decimal?
Fraction. Let's do
Fraction.
fraction.
So, because they're all equally likely. Right?
Yeah. 0/4,
hmm
900/4. Yeah.
So just tell me what you got.
I got 800.
Yep. Okay. So
Hmm.
good. Did you do the expected of winning is equal to your initial amount plus the
Hmm.
expected of winning on fourth
Hmm.
spin? Okay.
Hmm.
800 plus 0. Right? Because it is your fourth time, right? So, alright. So, should you take that spin or not? Do you think you should take that spin? Do you think you should spin the fourth time?
No, I mean, the fourth time?
Yeah, because right here, right? Suppose a contestant already won 800 bucks, right? Right? And remember
Hmm.
the idea of like, let it rise in the casino, like let's keep gambling. Do you think he should spin the wheel the fourth time, which is exactly what this question's asking? He's choose to spin the wheel again, which is the fourth time. Do you think he should spin the wheel a fourth time?
Yeah, I mean, I can tell cause mean and her current winning are the same.
Hmm. What is the winning on the fourth? So, did you understand my question? Should Yes or no, do you understand the question? Should the player spin a fourth time? Do you understand the
Yeah,
question? Okay.
yeah, yeah, yeah.
You said yes or no, and what's the reason?
I I mean, it's like 50/50.
Oh my.
I mean,
Uh,
if the if she is winning like 900 and the mean is 800 now, then she shouldn't.
come on.
But the
So,
mean stay the same.
mm, mm-mm. Look at this. So, what is her expected to win on the fourth? So, her initial winnings, right? Her initial winnings amount is 800 bucks, right? She's already up
Mm-hmm.
$800, right?
Mm-hmm.
Right? What is her expected winnings, right? After after fourth spin. It's what?
$800.
Which is the same, correct?
Mm-hmm.
So should she spin? No, because does it increase or decrease?
Because it neither increase or decrease, so
She
it's her
should.
choice. I mean,
Yeah, no, she shouldn't spin. That's what I'm telling you. Because
why
the
not?
expected value is the same.
What if I tell you she has a 3/4 chance
No, but
to win
the
more money?
expect. No, no. You're giving me a probability. When we're thinking about should or we should not, in this
I mean,
case, we're looking at
if
the
the winning
expected
after
value.
fourth spin is greater than 800, then she should spin. If it's less than 800, she shouldn't. But if it's equal to 800, it's we can tell, I think.
Okay, 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 okay,
Yeah,
okay,
I get
okay,
you. I get
okay.
you. I get you. I know what you're talking about.
Okay, that's fair. That's fair. No, okay, that would be a fair assessment. Okay. All right, let's do the fourth one. Now this is where the child test comes in. Okay,
Hmm.
because oh well, okay, sorry, shoot, I kind of gave it away. Looking at part C, what type of question? How do you think the player could conclude? So read C out loud to me, and I want you to pick out the word that's going to tell you what test to use. Go ahead.
The contestant who lost at this game alleges that the whale is not fair. In order to check the fairness of the whale, the data in the table below were collected for 100 spin of this whale. Based on this data, can you conclude that the four outcomes on this wheel are not equally likely? Give appropriate statistical evidence to support your answer.
Okay, looking at this, there are two things I want you to pick out. You could also pick out more, but what are the things that you could pick out that will tell you what to do in terms of like how to answer this?
Equally likely
Okay, okay, before that though.
and
Statistical
for
evidence,
what?
like this is a very good indicator of it being a one of a like hypothesis test. Okay?
Uh,
Now
uh-huh.
you picked out the second word, not equally likely. This reminds you of what sort of test?
Uh, good of fitness.
Good, right? Because that is a comparison of right? That would be a comparison of right?
Mm-hmm.
Proportion,
Oh yes,
right?
proportion.
Right?
Yeah.
That's how you know it's a goodness of fit. Okay?
Mm-hmm.
All right.
Yeah.
So, do you want to work through that?
Okay.
And tell me what you got.
Should I do the full test?
Well, you in as on the tests, yes, right?
You
But
need
for
to do the four step.
yeah, but like you don't have to write it out. I just care about the final answer. But on the test, you have to show all the parts, right?
Okay.
Okay,
Okay.
right. But you're going to tell me this is my null, this is my alternative, right? Blah blah blah. I did some math. This is what my right. I'm expecting, the chi-square value, right? The degrees of freedom, the p-value, okay, right?
The chess square is 4.07 and the
Eh,
p-value
that's close. Your chi-square is what?
4.0697
4 point. Okay. Well, 6. Okay.
and p-value is 0.254.
Point two what?
254.
Okay. Yeah, that's close. That's close. Okay.
How close should it be in order to get it correct? I mean,
No, because you're not that off. You're not that off. Because
uh,
if you look at the, I'm gonna show you the answer. So keep going.
okay.
So tell me, do I reject or not?
We fail to reject H naught
Why?
because our p-value is greater than our significance level.
Yep. So that was your answer, right? Oh wait, what was your H naught and what was your HA? I just
H
want
naught
to. Uh huh.
is H naught is let me see. Uh, H naught is
It always follows this format.
the four outcomes on this wheel are equally likely, and the HA are not equally likely.
Okay. So most of the time you're gonna see exactly how I wrote it. You're gonna see like something like this, right? You're gonna see something like this most of the time, right? Right?
Mm-hmm.
Or here it would be like wheel or something, right? Okay. But the answer that I posted for you, you would have seen it. It shows that. So here, let's grab
Oh
that.
yeah, we can, but we need
Okay.
to explain those variable.
Correct, right? Yeah. So here you see where you were a little bit off. You were like 4.02, right? So I think it's just the way you're rounding it, but you should be okay there, right? Your p-value was good and you had enough value and you realize that right here, your p-value is greater than the alpha value. So, and
Why?
that's, you concluded, fail to reject
But
H naught.
will I be marked off for that?
Um, the way, if you look at the way they grade it, you're close, so I would say no, but I don't know how I don't know how
For
far
some,
if you were a 5, if this was a 5, yes, right? I think they would mark you off, but you were at a 4.02, right? You're within like 1/10 of the answer. So, right? That's reasonable. It's if you're
but I
off
use
by
my calculator
magnitude
to find the
bigger than
answer.
no.
How can it be like that off?
Hmm?
I use my calculator to find the answer.
Yeah. Yes, that's what maybe it's a rounding that they're using differently. Right?
Wow.
It's just rounding, right? That's what happens when you have, exponents. Okay, good,
Sure. Yeah,
right?
yeah.
But again, but the way they're grading it, if I didn't give the whole like the rubric, but they care about this part the most,
Okay.
right? And this is your statement, and you have this to prove it, and your number wasn't off, so that would be a full point. Okay,
Okay.
good.
Okay.
All right, so
Yeah.
that's good that you realize that this is a chi-square test, right? And
Mhm.
do you notice why it's not uh, what's the other one? Homogeneity, or do you notice why it's not that, or independence?
Mhm.
Why is it not the other two chi-square tests?
Because it only has one categorical variable
There,
and one population.
there you go. That's it. Right? It's that easy. Okay.
Mhm.
All right.
Mhm.
Next one we are going to look at is this one, the manufacturer question. And I think, yeah, and this is the whole one. Okay. Looking at, read this and tell me what you would use to solve it. Let me just grab this. So, read the scenario. I want to hear it.
Which one?
We're doing 6. Read me the scenario.
A manufacturer of the th- thermostats
Mm-hmm.
is concerned that the readings of its thermostats have become less reliable. In the past, the variance has been 1.52 degree Fahrenheit squared. A random sample of 10 recently manufactured thermostats was selected and placed in a room that was maintained at 68 Fahrenheit degrees. The readings for those 10 thermostats are given in the table below.
Okay.
Yeah.
So, right.
So the
Mhm.
variance is standard deviation squared.
Yes.
Okay.
You know, standard deviation and variance are like almost the same thing. Like the only reason why there's like a difference is because they want one of it to always be positive.
Oh,
That's the only reason. Because there's some math thing that like negatives
but
really
standard
screw up.
deviation can be negative as well.
Yeah, yeah, because variance is the squared one, right? Yeah. Variance is the one that they always wanted to be positive. They always wanted something to always be positive.
Okay.
Okay. But they describe the same thing, essentially. Yeah.
Okay.
Okay. All right. So what do you think? Like how do you like what sort of here they state and the null hypothesis, right? Can you state that for me?
Mm, hold on. Can I say that uh the readings of their thermostats are reliable?
That's your null
Yeah.
has became less reliable. Okay, so they're baseline, right? Your null is baseline, okay?
Mm-hmm.
And your hypoth and your HA?
Hold on.
Uh-huh.
Wait, H naught is le less reliable or
No, 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 no. Remember, H naught is describing how things are right now.
how things are right now?
Yeah, the status quo, right?
So it's reliable?
Yes. Well, yeah, yeah, yeah.
Yeah,
Mhm.
yeah, yeah. Like what I said before, right?
Mhm. And HA would
Okay.
be it's what?
HA is the thermostats are less reliable.
That the way you're answering it makes sense. Like I totally agree, but they have a different answer. Oh
How
man.
did it say?
Huh?
How
Here,
what did it say?
no, I'm gonna pull it up for you. This is
Okay.
interesting because the way you're describing it makes sense perfectly, right? This is the way they want the solution, right? So it right here, it says it's equal right now. It's perfectly equal. Their temperature is perfectly equal, or the variance is perfectly equal, and here the variance is greater than 1.2. No, 1.52.
Okay.
Right? So what you said makes sense here. Does that make sense? So your answer would be correct. Here they wrote it differently in a different word format.
Okay.
Good?
Oh yeah, yeah,
This is
yeah.
what you said. Equally, right? It's baseline, and this is if the temperature is different or greater. No, yeah, it's greater. The variance is greater than 1.52.
Oh yeah.
Okay? Because this changes. This becomes a one-tail test,
Mm,
right?
mm,
Because of the inequality.
mm-hmm.
Okay? Good? Alright, so good. We have that. Here, do you see how it some questions they will actually already tell you what to use? Do you see that?
Yeah. Yeah,
Okay.
yeah, yeah.
So do uh you can do part B if you want, but I care about um B and C. I care about B and C. Okay? So calculate that out for me and tell me what you got.
Wait, what does that mean? It can be shown if the population of normal distribution, the sampling distribution.
Because they're no, they tell you it's a normal distribution, so you can do the chi-square test.
Mm.
Okay. Because here, what you're calculating here is probably is the expected, right? You could almost say that this is what the expected data is, right? So calculate that out and tell me what you got for part B, then do C. Tell me when you got something.
Mm-hmm. Part C is 12.0506.
Uh, part B, right? Yeah.
Mm-hmm.
Mm-hmm. Good. That's correct. Straightforward calculation, right? That's just plugging it in. And do you understand
Mm-hmm.
how you got 9?
Yeah,
Okay.
degrees of freedom.
Yep. All right. Good. Okay.
Mm-hmm.
And part 2, no, part C. Tell me if we reject it or not. No, give me the p-value for that one. Right? That's right. Number C is using the test statistic from part B and the chi-square. Yep. All right, because you're gonna test the hypothesis because this is your expected. Okay. Now you can test it. Okay.
So what what do we have from part B? What is that
Right here, the
number?
12.069. Remember? Okay, so remember here.
Mm-hmm.
Remember all this. Do you see how we got the expected population was like one fourth, one fourth, one fourth, one fourth. Like we have an
Uh-huh.
expected value here. Here, this is the expected value for the temperature.
Expected value for the
Mm-hmm.
temperature.
Let me show you here. Let me pull it up for you here. All right. So part. So this is here. Look, because remember, the test statistics of the chi-square, right? We said it was 9. It it's the chance of it succeeding the observed value of 12.069. So remember, this is the this is the theoretical value that we calculate,
Mm-hmm.
right? And we're trying to see if it goes above it or not, right? Because remember your HA was saying if it is equal to, right? We're going to say, hey, is it really equal to
Oh,
this?
about variance.
Yeah, that's why you calculated that. This is a description of in the question. This right here is
Uh-huh.
your is a description of your uh the temperature.
Expected
Yeah.
chi-square.
Mhm. Okay.
Is it?
Yes, it's okay. So you should have gotten, pull it up for you. You should have gotten something that looks like this. Okay, that the probability of the child square is going to be greater than 12.069, right?
Uh-huh.
And that's only 0.2094. This is in the calculator. Okay?
Wait, what is that?
You calculate this using the calculator.
Also, we need to find the chi-square for the whole thing. That one?
Correct. Okay?
Wait, hold on, hold on.
Here, let me pull that up.
Mm-hmm.
Right? Because here's your null, here's your expected, right? Almost, it's like the expected value or your theoretical value, right? Here, it gives you your p-value from these, um, from calculating the child square, the chi-square here.
Mm-hmm.
Okay? And the fact that we use the alpha value of 0.05, right? We say we cannot reject the null, right? Because it does not fall within the rejection region of zero point 0.2 or 0.25. Okay? And this comes from the chart of the child square. Question?
Okay. Oh, so we directly use the 12.069. So 12.069 is our chi-square.
Yes.
Oh.
Because you like remember remember how here the child square is given in that weird right here, right? This weird formula. Most of the time
Mm-hmm.
the child square is given in this format, but here they give it to you already. They tell you like this is how it's calculated here for this problem. They give you this in
Oh,
this problem. Okay?
okay.
Right? Because or you could have here or you could have gotten, you know, because from here you would have to, right, do at right, you can use the data here and figure it out if you want, but that's going to take you too much time. Right? It's the same process. Does that
Mm,
make sense?
okay.
Okay? Right? You could do it
Mm,
if you want. It's the same answer. Okay? And then you could decide if you're going to reject it or not. Okay?
mm,
Good?
mm,
So do you see how the child square is sort of asked on the FRQ now? Are you
mm-hmm,
getting a better gist of it? Are you getting a
mm-hmm.
better understanding? Okay. Let's see. What's the next one? Uh, uh, hold on. What question that? Question 6? Did I pull up question 6? Hold on. Did I not include question 6? Hold on. Uh,
Question six for what?
oh yeah, okay. That's good. Oh, okay. So here, because the question continues after this, for that, it continues. Um, I think you no. You okay? You don't need to do that. You're fine here. Then. Oh, okay. We gotta do this one. Okay. This is the next one I want you to look at. Right? Uh, just bring it out here. Okay. All right. Okay. So read the scenario. like out loud so I could hear it. Yeah.
So okay. I think there's still part E on that question.
Yeah, no, no. Like I looked through it. Like you could go over it by yourself, but it's not that important. Like it's
Okay.
just graph. Or do you want to go talk about it? It's just
No, no. Okay,
graphical.
sure, sure. Let's move on. Yeah.
Yeah. Because like histograms are pretty straightforward with you because we already talked about like the rejection region and everything. So
Mm-hmm.
okay. All right. You want to read this? Yeah. Read me this scenario.
Okay. A study was conducted to determine where moose are found in a region containing a large burned area. A map of the study area was partitioned into the following four habitat types. The figure below shows blah blah blah. Yeah.
Okay. Here's that. Right.
The proportion of total acreage in each of the habitat types was determined for the study area. Using an aerial survey, moose location were observed and classified into one of the four habitat types.
Okay.
The
Right.
results are given in the table below.
Now Now you should already notice what does this remind you of? What sort of test?
This one,
Mm-hmm.
good of fitness.
Right. But right.
Uh,
This is still good. No, no, hold on.
Wait,
This
this
is
is not good of fitness. Hold on,
it's okay.
give me one sec. Uh, is it homogeneity?
Because you think there's two populations, right? Is that what you're thinking? Because there's two populations. What are your two populations?
Oh my God. Yeah, I think it's one population.
Right? So do you see how the chart,
Yeah.
right? The chart, like you got screwed up by the chart. You're like, well, there's two columns, right? No, they're still
Uh,
talking about the mooses. Moose is still population. It's only one population, right?
mm-hmm.
Right? It's still goodness of fit. Okay? And you're like, look, these are the categories, right? One, two, three, four, right? Inside the burning area, outside, like inside the burning area, near the edge, outside the burning area, outside the burning area, not near the edge, right? These are our categorical.
Mm-hmm.
Okay? Good?
Mm-hmm.
Alright, so here, do the first part, give me the null and the. So read, right? Give me what the H naught is and what your HA is. So give me H naught, then you're going to give me HA. What do you think?
H naught is the
Hold on, hold on.
most distribution is
Hold on.
independent.
Wait, wait. I just wanted to tell you this. I hope because this is probability and this is the like n, right? Right? Do you see how this is the probability, right? Or proportion, right? Because you could almost think about this in terms of probability, right? Does this make sense?
Mm-hmm.
This is your count. Do you see how, right? Doesn't this remind you of something?
Mm-hmm.
Okay, right? That's how another way you can see it in terms of the chart. They're not two different categories, right? This is really just a probability. Okay? Alright. So sorry about that. Okay? Okay.
Oh
So
wait, so this one is what? What is this one?
this one is goodness of fit.
Still goodness of fit?
Yeah, this is right? Yeah, the chart. I was trying to give you a better understanding of the chart. This is right
What?
category probability. What do you mean? What?
Why is still goodness of fit?
What do you mean? There's a probability. There's one population, and you're trying to see here conduct a appropriate to test your conclusion,
Oh my.
right? You're trying
Oh
to
yeah, one
assume.
category.
Where is it? The study right here. Here's the keyword. The study expects the number of moose observed in a habitat to be proportional. Keyword proportional to the amount of acreage of the type of habitat. So that's the keyword, right? Proportional. Proportion. Goodness of it.
Oh yeah. Wow.
It's a lot of like. Can you just pick out that word? That's why. That's why I'm trying to get you to see the words. Okay.
Mm-hmm.
Good. All right. So what do you think H naught is and what your HA
H
is?
naught is moose observed in the habitat are proportional to the habitat area.
Okay. Okay. And
It's not proportional.
okay. Good. All right. And the other one, it's not proportional, right? Right. That's what you
Mm-hmm.
said, right? You gave me this
Mm-hmm.
answer. You gave me the middle answer. Perfectly accepted. Good.
Middle answer? Oh
Yeah, you
yeah.
gave me this one. That's what you said. You gave me the
Okay.
middle
Yeah.
answer, right? So,
Uh-huh, uh-huh.
right. But here it's the same thing. The third one, they just list out the proportion. Do you see that? That's exactly how we do it, right? P1, P2, P3, P4. Okay?
Mm.
Or you could just make it a straight no, right? Do they prefer it or they not? Do they have a preference or they do have a preference?
Mm.
Okay? So those
Mm.
are they're worth the same value because you're going to test it the same way.
Mm.
Okay? All right. So after this, right? You give me the HA, right? Run your tests and tell me what you got.
Okay. Hmm.
What's your degrees of freedom? Give me your degrees of freedom first.
3.
Okay. All right. Okay. That makes sense, right? Even though there's
Mm.
okay. Good. Okay. All right. And your child square is your straightforward. You know, did you get the expected value though?
Yeah.
You know how to find the expected value, right?
Yeah.
Okay.
So the chi-square is 43.67.
Okay. 43.6. All right. Good. Okay.
Yeah.
Right. So just in case, like, because some people might watch this video, because the website that I'm using is my classroom website for all my kids, right?
Ah.
Because you already know how to do it. But everybody else, you know the 39.780, the 11.877, this expected value here that you're calculating comes from using this n, right? 117 times the probability, right? Will
Mm.
get you the first one. 117 times 107 will give you the second one, right? You're not using this as your end. You're using the total. Okay? Good?
Mm.
All right?
Mm.
That's how you got your 43.689, right?
Mm-hmm.
The p-value is how you get the calculator. So what can you conclude then?
So
And
we.
right, that's this part,
Yeah.
second part. Assume the condition. Right now, what can you conclude? After you run this test, you have to write the conclusion in the context of the problem.
Mm. We reject H naught.
You what? So you reject H naught. What the, like? Remember, you have to let me write this. You have to state the correct conclusion in the context of the problem. So when you did this for me, right?
Mm.
I need you to do this for me now. What does that rejecting H not mean in the problem?
We reject that. Uh,
We reject and insert your H not statement.
yeah, if not, we reject that moose distribution is proportional to the land habitat area.
Because there is strong evidence.
There's a strong evidence.
Right? So that's your first sentence, right? Blah blah talking about your H naught. Then you have to say there is strong evidence. Then you go blah 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 blah. Right? Then you
Uh-huh.
insert your basically your HA statement.
Mm-hmm.
Does that make sense? So
Mm-hmm.
that's sort of the format of how to do this. Okay?
Mm-hmm.
Good?
Mm-hmm.
Alright, so there you go. There's different types of answers. So here's an example the College Board gave. Right, you could have wrote there the data is not consistent with the research expectation. Right, that's your expected values. Right, here they just talk about the null. Okay,
Mm-hmm.
part you have to go. There's another part to the question. Where was it? Relative to the proportion of the total acreage, what habit types did the moose seem to prefer? Which one do they prefer? One, two, three, or four? Relative to the proportion of the total acreage.
Mm.
I'm gonna make your life easy.
Mm-hmm.
Hold on. Let me put this.
Is it habitat 3?
Well, why did you pick three though?
Because the the density, so the population density for moose in habitat 3 is the greatest.
No, when they're asking, so we know that. Hold on, where is the question? When they're asking for this part, where is it? Where is it? Here. Relative to the proportion, what habit did the moose seems to prefer? You want to go back and look back at the expected value, right? So
Mm-hmm.
looked at each. Can you see this or is it too small?
Yeah, I can see it.
Okay, right. Do you see the first one you calculated? The first expected value that I was talking about, 39, right? And the other one was 52. Do you see how close that is? So this would be a very, so this would be a very, this would be a small number, right?
Mm-hmm.
Right? This too, correct?
Mm-hmm.
Right? But this, the one that I'm gonna, this are going to be large, correct? Does that make sense? Because of the expected value here is so small. The expected
Mm-hmm.
value here are so small. Does that make sense?
Mm-hmm.
That's why the answer is type 2 and type 3.
I think there's a like. Hold on, let me refresh. It's a pretty
Type 2
big
and
lag.
type 3 prefer is prefer because the expected value is so uh, small when compared to their observed.
Oh, I see.
All right. Okay. Does that make sense? That's
Mm-hmm.
what I
Mm-hmm.
was trying to say. Right. Good?
Mm-hmm.
Okay. Can we move on, or do you have any other questions in regards to this?
Yeah, I understand.
Okay. So I think this is about it before we go to confidence intervals, right?
Mm-hmm.
Hold on, let me see this. I think this is it before we go to confidence interval. No, there's one more, but yeah, there's one more, but you could do this by yourself. Um, yeah, yeah. We're gonna talk about confidence interval next. But you see, of all the problems that we did you notice how did it really care if it was independence, goodness of fit, or independence? Right?
Independent good out of fit.
Did you notice that none of the questions asked for that?
Uh-huh.
Right? Okay, that's what I'm saying. In the FRQ, they don't really care about the difference of the three, right? They just care if you know how to run it and interpret it. Does that make sense?
Hmm.
It's only in the multiple choice that they might ask you the difference between, the
I think
independence,
this year they
goodness
had
of
a
fit.
different test.
Huh? No, they didn't change the AP stats test. It follows the syllabus of it is still the same.
I mean, what if the test like this year they have the homogeneity and independent?
No, it's the same reason why they don't ask you to calculate power. They just want you to understand power, right?
Oh, okay.
Yeah, it's okay. Okay, good.
All right.
Okay, you sure?
Yeah.
Do you have any more questions on the chi-square test?
Yeah, I think we're good.
Okay. Then the second part that you wanted to talk about was confidence intervals, right?
Mm-hmm.
So, what's your concern about confidence intervals? Like, what's your general question about confidence intervals? Do you have a general
Uh,
question, or like, do you need like a review on what is the confidence
I
interval like
mean, yeah,
visually,
I just want to review.
or its
Is
application in the problem? Like, because I have a PowerPoint that goes over like that, or do you want to go to the formula and look at that, or do problems? Like,
yeah, let's do problems.
okay. So you understand that there are three types that you're going to be dealing with, right? Large
Yeah.
sample population, right? So this
What
is a
was it?
so there are three types of scenarios you're going to do confidence intervals with, okay? The first one is large sample confidence intervals for a population,
Mm-hmm.
okay? Right? So here this is, right? The second one you're going to do is small sample confidence interval for population mean, right? Do you see how this is large? Then there's going to be sample small, and that just it now this becomes the t critical value. Good.
Wait, hold on. What, are you showing me something?
Yes.
I can see.
uh, what? It's not on the computer screen. I swear it's on the computer screen. No. What
I mean, it's something is covered.
do you mean? What? Hold on. Thank you for telling me. Hold on. Let me go check that.
Oh
Why?
yeah, it like
Okay.
floating on the screen.
Good. Can you see it now?
Oh yeah.
So, the first one is the large sample confidence interval for a population mean, right? Z critical value. Good.
Mm.
All right. This is where these they're given to you, so I don't think you need to memorize this, right?
Mm.
Then next, you're going to be given your small sample, right? Notice that this is your when you use your degrees of freedom, okay? And this is your t critical value. Understand that the large is z critical value and the small one is t critical value, okay? Good?
Hold on. Mm.
Just some definitions here, okay?
When do we use T critical value?
Right here for small sample and the population distribution is normal. So when your size is like most of the time is when your sample size is like 10 or less.
Mm-hmm.
Okay? And the last one is this. Large sample confidence interval for a proportion. Okay?
Yeah. And also, can you, I think, like your image is covering the information.
What?
Like, how to say?
That makes what? Uh, what's covering?
Like, uh,
My camera?
yeah, your camera, yeah.
Hold on. Can you see it now?
No, it's still there. Hold on, I think there's a lag. Yeah, we're good now.
Let me see. Yeah, okay. Good? Right?
Mm-hmm.
So you should have this down, right? You should also have this down for the sample, and this one is for your uh, population proportion. Okay?
Also, one more question.
Yep.
So, what is sigma here? The for the general formula?
Sigma, what are you referring to? Oh, right
The
here.
standard deviation? Yeah.
Since n is large, the unknown sigma can be replaced by the sample value s. So the sigma here, you're asking about this value?
Oh, so sigma is the standard deviation for the population?
Yeah. Hold on. I got a really good picture for you.
Okay.
Can you see that?
Not yet. Oh, okay.
Do you see that?
Mm-hmm.
Okay. Right? So, I wish I could draw on this. So, let me print screen. Let me grab a picture. Drop that here. Boom. Okay. So, notice that. Hold on. Let me bring this up. Okay. Right. So notice that here there's this population, correct? Okay.
Mm-hmm.
Um, then this population they are given. Let me use red. Right. This population, you would understand has a um, the um, has a has a standard deviation associated with it, correct?
Mm-hmm.
Okay. But as n tends to infinity, right? As your population, as this gets large enough, right? As your sample here gets large, okay?
Mm-hmm.
Your this becomes
are you drawing something?
yeah. Hold on.
I
You're
can
gonna see it.
see it's there on the formula page.
What? Stupid screen. Really? Oh my. Why is it? Why does it do that? It captures the screen. Hold on. Thank you for telling me. Uh, hold on.
Mm-hmm.
Now, okay, let me capture this window. Add screen capture. Okay. Do you see it now?
Give
We're
me
gonna wait.
5 seconds.
Yeah. Okay.
Yes, the
Okay.
PPT one, right?
Yeah. So notice that you see how the sample is so small, right? So the sample here, the population here, um, the sample here has a uh, standard deviation, correct? Right? It has a standard deviation.
Mm-hmm.
Okay. Now, the standard deviation of the sample is going to vary depending on the size of the sample size. However, once the sample size, right, this color, let me see this color, once this color becomes the whole population, oh my gosh, I kind of wanted to make it the whole thing. So
Mm.
once, right, the sample becomes the whole population, this goes,
Mm.
this becomes uh, the becomes S now, right? That's the only difference between the formula, okay? That's the difference between the two. That's the difference between the formulas. Hold on, I'm gonna bring it back. Okay, that is
So
the
sigma is for the population or the sample?
yes. The um the sigma. Hold on, it's gonna go back on the screen.
Mm.
So the X bar is referred to your sample, your sample's um, average, right? Your sample's mean. This is the standard deviation for your sample, correct?
Mm.
Right? But as soon as your sample gets large enough, which is when it almost becomes the population, right? When you
Mm.
sample a very large number, your standard deviation basically becomes S. It basically, right, the standard deviation of the sample is actually the standard deviation of the population.
Mm-hmm.
That's why it's replaced.
Okay.
Good. That makes
Yeah.
sense, right? When the sample becomes big enough, the standard
Mm-hmm.
deviation is more likely to be the standard deviation of the sample is more likely to reflect the population,
Mm.
right? Okay, good.
Mm-hmm.
Okay, here are your conditions for the population mean, right? The small sample, right? S, right? Um, right. Same thing here. Okay. And your last one is just your proportion. Okay? Good. We're going to see how it's applied in the problems.
But why do we use T? I mean, when the sample is small enough, we use T. What
Be-
is the limit for?
Say that again.
So when the
Why?
sample is small,
Uh-huh.
we use
T.
T.
Uh-huh. Why do we
So
use T? Is that your question?
how small does it have to be in order?
Most of the time it's I think you guys there's a calculation for it, but I think for you guys it's anything less than 10. Well, less than 30. Hold on. Let me pull up my t-test. Small sample test for population. Um, because there's a reason why. Let me see. Where is the t-test? I think I have to get back to you on that one.
Okay.
T-test. T-test size. Is there a formula for it? Hold on. That's actually bothering me now. Hold on. This the t-test. Oh, here. Sample size required. Maybe this is gonna give us the answer. No. Nope. I think yeah. There's no rule for it. Just go stick with 30. Ask your teacher. Maybe the like college board like you know how we always make alpha like 0.05, right?
Mm-hmm.
There most of the time they stick to the number 30, right? 30 for
Okay.
the anything less than 30, you and use T. But ask your teacher. I don't know if the college board has a different stance on that. Okay?
Mm.
All right. So let's do the problem now. All right. So here is the first one. Okay. Do you want to calculate it or do you want to interpret? How do you want to work the confidence interval? Because the first question I have is more of an interpretation.
Yeah, let's do both.
Okay, so the first one is just a interpretation one.
To increase business, the owner of a restaurant is running into a promotion in which a customer's bill can be randomly selected to receive a discount when a customer is printed. A program in the cash register randomly determine whether the customer will receive the discount. The program was written to generate a discount with probability. However, the owner is concerned the program has a mistake result of generating. What is hold on? Is concerned that the program has a mistake.
Do you know what the confidence interval is? Do you know what are the two numbers?
Mm-hmm. Yeah.
So I got confidence interval is 0.09 and to
0.21.
0.21. This represents the what does this represent? The probability of what? The percentage. This is the
The
percentage of
percentage that interval the interval has the interval 0.09 to 0.21 has a p chance to capture the actual value of the
the
mean
bill.
probability.
Okay, what? Say that what? Wait, which includes the variable, which therefore it is. Does the confidence interval provide convincing statistical evidence that the program is not working as intended?
No.
First of all, this wouldn't make sense. You can't use. Okay, why doesn't it not make sense? I'm sorry. You're answering the question.
I mean, what was the question again?
Right here, the first part. Does the confidence interval provide convincing statistical evidence that the program is not working as intended? Yes or no?
No,
Why?
because the interval actually captures the stated
Captures.
proportion
Which is
0.2.
what? Okay, yeah. Which captures the stated uh 20%.
Yeah.
Okay, good. Okay.
Mm-hmm.
That makes sense, right? Because
Mm-hmm.
that's what he was wondering. Okay. Good.
Mm-hmm.
Here, does the confidence interval provide convincing statistical evidence that the program generates the discount with a probability of 0.2?
Do we need to do a test on this one?
Why why would you think you're supposed to run a test?
Because it talks about you mean the confidence interval.
Hmm. So,
Okay. Nah, not a test.
when a customer's bill is printed, a program determines whether is will receive a discount. The program is written to generate a discount given 20% of the bill in the wrong one. However, this consider has been taken generating the intended. So 20% of the bills are supposed to get a discount, right? Right? And the confidence interval says that 9% to 21% of the bills will get a discount, correct? Now, and we said that is there enough evidence to show that 20% fits? Yes, because it fits in. Now he asks, wait, does that also prove that that they will show a where is it? Prove convincing statistical evidence that it does it at point 2. What do you think? No, right? Because
No,
if
I
any
yeah,
values
I
if
know it's
any
no.
values falls outside the CI, then it is not possible. Okay? Does that make sense?
If any value falls outside
Outside
the
this
so then it's not. Why? I mean, what does it?
That's what the confidence interval is telling us. The confidence interval is giving us a measurement of things that is possible, right?
Yeah, but what
hmm
does that have something to do with part two?
Because it's asking, does the confidence interval provide convincing statistical evidence that the program generates the discount with a with a probability of 0.2 or 20%?
So?
So it doesn't, because the values falls outside of zero point zero 0.09 and 0.21.
Point two is for inside.
No, 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 no. Read the question, right? Because this, okay. Here, it. Okay, hold on. Can I highlight? I can't highlight this. Can I highlight this? No. Look at the word, right? This here, it's evidence that the program is not working as intended, right? Not
Mm.
working as intended. Okay? But this one, it says that it is working as intended. There's a difference in the question. This one is not working as intended, right? So if it fits within this confidence interval, right, it is not it is working as intended. Does that make sense? It's tricky. It's tricky because here for the question frames it in a negative way. It says is not working, and this one is asking that it is working. This no, that doesn't make sense to you. Okay, so let me give
So
you
is it working or not?
with point two. No, because it falls out because it falls within the values.
If it falls within the value,
Hold on,
then
hold on, here. Hold on. Let me grab this for you. Okay.
the answer is
Hold
the
on,
confidence
hold
interval
on.
includes value from 0.09 to 0.21. So any value in that interval is a plausible value for the probability the computer is using it. Yeah, okay, I understand. Yeah,
You sure?
yeah.
Because it's the way they're framing it that made it confusing.
I
Okay?
mean, it's not value falls outside of the confidence interval because there are so many values in this interval. We can say it's 20. It's just 20%, right?
Mhm.
Yeah. Okay, let's
All
move
right.
on.
Okay. Uh, next one. Oh, that was just the answer. Uh, question. Oh, right here. Question 3.
Mm-hmm. Mm. Oh.
What does the 9% confidence level mean in the context of this question? Want to estimate 95% confidence that the poor portion of households in this country owns at least one dog.
The 95% confidence interval means that the uh the statistical value is 95% confidence to capture the actual statistical parameter.
What? Not okay, but you're not giving it into me in the context of the question.
Oh,
So
you want me to
what's
give?
the
Oh,
yeah?
oh,
What's the experiment? Like what's the like what's happening here? Like what is someone
okay.
doing?
Can I mention interval in part A?
Sure, but I'm asking you like what is like so the human society wants to estimate, right? So they're going to do what though? They're gonna go at like so a humane society person, right, that works for them is going to survey, right, a household, correct?
Mm-hmm.
Right? Survey a population of people and ask them what? And ask them what?
If they have dog.
Do you own at least one dog? All right. The person, um, then the people here can say so the sample, the sam, how'd you sample will say yes or no, correct?
Mm.
Okay. All right. Then, right. Then, okay. Then, right. Let's say the first time that they did it in 2010, and um, they got 80. Let's say they sample 1,000 people. We'll say yes or no. They did this in year 2000. They got 800 to say yes, right? Then they did it in 2001, and they got 900 to say yes. Okay? Then they do this for several years. Then what happens? They do this in several years. Then what happens? The confidence intervals describes what? Of 95 describes what? What do you think? I'm giving you better context so you can answer it better. I can even give you the confidence interval here. I'm just making up some numbers in this case. Uh, 640 to 920. If the confidence interval is this, what does that mean?
The confidence interval from blob to okay. The confidence interval has 95% chance to capture the actual
No.
people.
In the context of the question. Okay, ready? Follow this. This is exactly how I
All right.
want to say, right?
Just you tell me, okay? You tell
Follow
me.
this format, okay? So say first of all, say this, right? Um, okay, I can be. Wait, hold on. In the long run, right? Blank, right? Here you want to insert CI level, right? In the long one, right? The interval. You can use the word succeed, or you can say the interval succeeds in capturing, or you can say you can also say the interval um, uh, the interval matches, right? Or you
Mm.
can say reflects it, completely, right? I think completely. You can use these words: succeed in capturing, matches, or greatly, matches, or reflects completely. Okay, the actual value, right? Then you want to insert the actual value here, right? Of population of pop, because that's what all confidence intervals does. This is what a confidence interval does by definition in all contexts of the problem. The population here is the owner.
Mm.
Does that make sense? So you want to follow this format. The keyword that they're looking for is this. This is how they actually grade that question.
In long run of taking random samples?
Yes, the reason why you have to mention long run is because remember of the law of large numbers?
Why
That's
did
the
you say
only.
in long run of taking samples?
Say that again?
In the long run of taking samples, taking random samples.
In the long run, in the long run of taking, yeah, of taking samples,
Okay.
okay? Right?
Sure.
Right? Then right? Then 95% of the, like, 95, I can be 95% sure, right, that this reflects the total population, right? That this number, that there are 640 owners through 920 owners. I can be sure, like, if I run the experiment, or if I run the survey 100 times, okay, 95 of the time the answer will be in the CI, and 5% of the time the answer will be outside the CI.
Mm.
Right? That's it, right? That's what that 95% of them mean, right? So the answer that they give you will fall within, or sometimes, right, it will be
Mm.
outside. Okay? Does that make sense?
Mm-hmm.
Have you ever gone to Disneyland?
Yeah.
Okay, you know the fast pass that they show you? They say you could return back, you can come back, and they give you a time, like the from the wait time is like 40 minutes.
Mm.
That 40 minutes is that 40 because they say the average wait time at this line is 40 minutes. Is it always 40 minutes at is the line always 40 minutes?
No.
No, right? It's like some of the times it's going to be what? So some of the times it's going to be what?
Less than or greater than.
Yeah, so give me some values. Give me some values.
38 to 44.
38, no, like sometimes, right? So like let's say you did it on a Monday, right? Like let's say you wrote it on a Monday and it was really 38, right? Here,
Mm.
okay? Then the next day you did it and it was really what? 41, right? Blah blah
Mm-hmm.
blah, right? 40 blah blah, and right? You collect thousands of data, right? The next year you come in, right? And you say you got a bunch of data, and now you're saying, hey, right, it's going to, right, based on all my data, okay, based on my data, I can say that the wait time should have been 35 minutes to 42 minutes, Okay? You're
Mm-hmm.
going you're going to be right 95% of the time. That's what it means.
Okay.
Good?
Okay.
Okay? Your estimate is going to be correct that percentage of the time.
Mm.
All right. So now do the now next part B.
Mm-hmm.
Give me the answer for part B.
No, because 39% is captured by the 95% confidence interval.
Correct. Good. All right. That's it.
Mm.
All right. Okay. And do part C.
If it's 95%, then
Do you know what formula you're going to be using for it?
yeah,
Okay.
standard deviation over root n, right?
And you know 6 is 6. I think that's large enough.
Six what?
6 because you selected how many household here? Oh, they don't tell you. Okay, never mind. Sorry.
1.96. So it's
Do you know what formula you're using?
Hold on, give me 1 second.
Let's see if I can pull up the AP test. Uh,
Is it 65.95? 66?
yeah, that works. Yeah, 66.
Okay.
Okay.
Cool.
So you grab this, right? I just wanna make sure you right. You use this, right?
Mm-hmm.
Okay. All right. And you use the 1.96. Yeah.
Mm.
All right. Good. All right.
All right.
And it would be a large survey. Good. And I think that's it. Right? Is that
Yeah,
it?
yeah.
Is that it
Yep.
for the worksheet?
Yeah, that's all.
Yeah. Yeah, that's it. I mean, that's so I just wanted to sort of give you a recap. Please understand that the FRQ will the only time that they're going to ask you to calculate the confidence interval is if it's part of a hypothesis testing question, right?
Part of the hypothesis.
Yeah.
Okay.
Okay, but like these are all the question like because I have a list like that breaks down like all the questions in the FRQ by topics. These are the questions that the confidence interval is asked on the FRQ, and notice that none of them were calculation. Did you
Mm.
notice that? It's all
Mm.
interpretation, right? That is how the confidence interval is asked on the FRQ. It's
Mm.
always interpretation, not calculation. And the
Mm.
worst is like the only calculation is the last part that we talked about, which was the like asking for a sample, the n value, right? The population. So that's
Okay.
it. Okay, but that's it.
All right.
Cool. All
Yeah, yeah, yeah.
right. Do
Thank
you
you.
like this way better, or do you like the
Yeah, yeah, yeah,
blackboard better?
yeah. Yeah, I think it helps a lot.
Okay. Right. You have the notes, right? That it captures everything. Uh,
Hmm.
what do you want to cover next time?
I want to cover everything about the slope regression line
Hold on.
and
You want to cover regression? Like
regression
what do
line
you? Okay, just
and
regression.
the
Mm-hmm.
interval and test for the slope.
What? Okay. Interval. So regression, interval. Okay. And
Mm-hmm.
slope. Okay. Well, what do you like? Can you give me like a what sort of question were you looking at? Are you referring to like the SSM stuff? That? Or are you
That's
like
what is that?
because there's a lot of parts of regression like what are you really trying to look like what's give regression is a big topic. Are what part of regression are you wanting to cover?
I want to go over everything about regression.
Okay, so you just want to do the 2 hours on regression. Okay.
Yeah, yeah, yeah.
Okay.
Like review every part of the stats. Yeah.
Okay. All right, from the FRQ perspective, right? Not because regression pops up on the FRQ via graph, but but calculations have popped up on the multiple choice. Do you want to go over both the multiple
Yeah,
choice
both,
and
both.
FRQ? Okay. All right. Cool.
Mm-hmm.
All right, that's it.
Okay.
All right,
All
take
right,
care.
thank you. Thank you.